Today's lesson is on the geosphere. What is the geosphere? The geosphere includes all the rocks that make up our planet Earth, from towering giants to epic canyons, to every grain of sand, and even to the partially melted rock within the mantle layer beneath us. But why is the rock down there partially melted? Within the mantle, a process called convection is constantly driving movement far below us. Convection is the movement of currents within fluids and is one of the major modes of heat transfer. We see this process happening all the time in our kitchens when we boil water in a pot. Except in the mantle, the hot material rises towards the crust. As it cools, it settles back towards the core, where it gets reheated. This creates a continuous cycle of convection currents, heating the Earth and producing the forces that cause tectonic plates. You see, the Earth's crust is divided into giant rocky plates, which move according to the convection currents in the mantle below. These tectonic plates are bigger than continents and cover the entire surface of the Earth. Movement along the boundaries of these plates is responsible for many of the geologic changes that we see in the surface of the Earth. Scientists have even used fossil evidence, soil samples, and rock formations to theorize that the continents were once connected. Hundreds of millions of years ago, in the beginning of the age of dinosaurs, this was the great supercontinent of Pangaea. The Earth has changed and developed a fair bit since then. Now let's take a look at what I like to call the plate boundary shuffle, or how these massive tectonic plates move. Along the boundaries of the plates, movement can happen in three main ways. Convergent plate boundaries are when two plates move toward each other. This intense impact of colliding plates can cause one of the plates to move beneath the other one. This can result in the creation of new mountain ranges or even deep seafloor trenches. Divergent plate boundaries are when two plates move apart from each other. Molten magma then fills in the spaces, creating new crust. We can see this occurring along mid-ocean ridges. These are mountain ranges that rise from the ocean floor when bubbled up magma is cooled by frigid seawater. Transform plate boundaries are when two plates slide past each other without destroying or creating new crust. But there's a whole bunch of friction between the plates as they move past each other. Since the crust is not exactly smooth, these plates will get stuck and build up an immense level of pressure. And when they do finally release and the plates move again, this built-up pressure can cause violent reactions in the Earth's surface. Which leads into the question of how does this affect us? Earthquakes are a mighty trembling or shaking of the ground caused by the sudden release of energy. They occur in large fractures or splits in the Earth called faults. Certain areas of the planet are riddled with faults and are far more prone to earthquakes, such as Southern California with its famous San Andreas Fault. We use magnitude to measure the amount of energy a quake releases. Seismologists or earthquake scientists used to use the Richter scale to measure earthquakes, but this form of measurement was really specific to California. For a standardized global form of measurement, seismologists developed the moment magnitude scale. On this scale, each consecutive number represents a 10-fold increase. That means a 6.0 earthquake is 10 times stronger than a 5.0. Intensity is also a measure of an earthquake and is based on the type and extent of damage and human experience. The biggest earthquake ever recorded happened in 1960 in southern Chile and was measured at a whopping 9.5. The local town of Valdivia suffered incredible losses, and this quake is still known as the Great Chilean Earthquake. Hopefully we don't see anything more powerful than this for a long time, but that all depends on what's happening far beneath us in the mantle layer. So let's review what we have just learned. First, the geosphere includes all of the rocks that make up our planet Earth. Second, a process called convection is the movement of currents within fluids and is one of the major modes of heat transfer. Within the mantle, convection creates the constant movement of heat towards the Earth's crust. This continuous cycle of convection currents produces the forces that cause tectonic plates. Third, tectonic plates are giant rocky plates which move according to the convection currents in the mantle below and cover the entire surface of the Earth. Movement along the boundaries of these plates is responsible for how our continents have been slowly moving apart from each other throughout Earth's history. There are three ways that tectonic plates move: convergent, divergent, and transform. Fourth, earthquakes are a mighty shaking of the ground caused by the sudden release of energy in large fractures of the Earth called faults. Seismologists or earthquake scientists use magnitude and intensity as ways to measure the power and effects of an earthquake. Thank you for joining me for this geology lesson on the geosphere. To prepare for the possibility of an earthquake, one of the most important things you can do right now is to figure out where your family will meet if you can't stay inside your house. It could be your driveway or perhaps your favorite tree. And starting to prepare an emergency preparedness kit would be really handy as well. As the old Boy Scout saying goes, always be prepared. Be well, my friends, and always remember that you are awesome. Subscribe to my channel to stay updated, and a like is always appreciated. We'll see you next time at Sam's Outdoor Science for Kids.